So this problem is from our homework 4.7a number 2. We're trying to find the dimension of a rectangle with this area to be 343 square meter, whose perimeter is as small as possible. So to do this kind of problem, we want to draw a picture when possible. So let's try to draw a picture. It is going to be a rectangle. So just draw a rectangle. And I'm going to enter the information inside this picture. So we have 343 square meter. That's the area. And what else we know? I think that's the only one we know. What are we trying to optimize? We're trying to optimize the perimeter. Okay, so try to make it as small as possible. So once I draw this picture, I'm going to organize information and say what are given and what are we looking for. So we're given the area here is 343 square meter, and we want to make the perimeter as small as possible. So we want to actually minimize the perimeter. And let's call this perimeter P. Now, we should also declare a variable for the length and the width. So let the width to be x, and we're going to let the y here to be the length of it. So declare the variable. After that, we're going to start the solution. So the first thing to do is to express the quantity that we're trying to optimize in terms of other variable over here. So when we do that, then we're going to have P is equal to, well, we have the formula for perimeter for rectangle is 2x plus 2y, right? Okay, so that is 2x plus 2y. So we express the quantity we're trying to maximize or minimize. In this case, it's minimized in terms of x and y. But this is two different variables. We want to express it in terms of only one single variable. So we're going to make use of other information given, which is this area here, to express, I think we'd like to express the y here in terms of x. So from this, we know that x times y is equal to 343. So therefore, y is equal to 343 divided by x. And now we're going to replace this y by 343 divided by x. Now by doing this, we have expressed this perimeter as a function of x only. Maybe we could simplify this a little bit. So how about, so one way to do this, you can take out the 2. So we can have 2x plus 343 over x. So that's a function of x. The next thing we do is we want to see what's the domain for this function. Because x is the width, so it has to be greater than 0. So greater than 0. And well, if the y is small, x can get very large in order to have this area, right? So x here can go larger and larger. The y is small, so it can go to infinity. Now the next step is to find critical number. So critical numbers, then we would take the duality to find critical numbers. The reason for that is because max and min will occur at the critical number or at the endpoint for a continuous function. So we're going to differentiate this. So the 2 here is a constant multiple, so put it in front. The duality x here is 1, and then 343 is a constant multiple. The duality of 1 over x, as we talk about that last time, it is negative 1 over x squared using the power rule. So last time we did this, the sum, the duality for 1 over x. So this is x to the negative 1 power. And when you differentiate that, then you're going to get negative 1 times x to the negative second power. So therefore, it's negative 1 over x. So this should be negative 1 over x squared. Now we're going to set this equal to 0. To find critical number. This is equal to 0 when 1 minus 343 over x squared is equal to 0. And now we're going to solve for x. So multiply both sides by x squared. We get this. So x squared is 343. Notice that x has to be positive. So we look at the positive root of this. Positive root of this, so 343 here, square root of that is 7 square root of 7. Okay, so if you use a calculator, 49 times 7, yeah. So this one here, it is the square root of 49 times 7. So therefore, square root of 49 is 7. So we have 7 outside, so square root of 7. So x is equal to 7 squared root of 7, and that's the only critical number we get because the critical number has to be in the domain. So it has to be positive. The negative square root is not in this domain, so we don't count that as a critical number. Once you get critical number, the next step here is to verify that this critical number indeed gives you the minimum parameter. So we're going to use the first derivative test. So the domain is from 0 to infinity. Now 7 square root of 7, this number here, let's look at the derivative. When the derivative equals 0 at this number, when x is bigger than this, then what happens here is this is going to be less than 1. So it's going to be positive. The derivative will be positive. When x is greater than this number, then this is less than 1. 1 minus that is positive. The positive here. When x is less than this, then the denominator is less than 343. Therefore, this will be greater than 1. So 1 minus that will be negative. Therefore, the perimeter is going to be decreasing on the left, increasing on the right. So indeed, this is the absolute mean because within the domain, the function is always decreasing on the left for this point and increasing on the right of this point. So this is a local mean, but also the absolute mean. So we verify that. Next step, you try to find also the y over here because they're looking for the dimension. So to find the y is equal to 343 divided by x. So divide by square root of 343. That's also square root of 343, which is 7 square root of 7. So the length and width will be equal. So basically, you get a square. The side will be 7 square root of 7. At last, we should want to complete sentence to answer the question. So the question over here is, find the dimension of the rectangle with this area whose perimeter is as small as possible. So we'll just say to minimize the perimeter, the dimension are 7 square root of 7. What's the unit here? Is that's meter. Meter by 7 square root of 7 meter. So, and then that's it. Now over here, the them users enter 7 square root of 7 square root of 7 meter, right? Does it make sense?